All right, story time. So, I have no idea how to segue into this. If a doctor came up to me and said, you have 1 year before you go blind, do with that information what you will, what would I do? One of the things that I do, I just couldn't think of anything of how I would tackle it. I do a lot of 3D design. Wait for this car to pass. I do a lot of 3D design. Like CAD stuff, not necessarily Blender stuff. Although I do use Blender, which is graphical models, not necessarily engineering models. But and there's just not really anything for blind people to be able to use that stuff. Technically, there's like OpenSCAD where you can write code, and there are things to help people who are blind write code. But I'm not going to use OpenSCAD. I want to be able to feel I want to be able to look at the thing that I'm working with. And if I can't see, well, then I at least like to feel the thing that I'm working with. And so my mind ran to those children's toys. They're called pin screens, or that's just one of the names for them. But you can you put your hand in it, and there's a bunch of pins, and out comes the other side, a mirror image of your hand, or I guess technically a one-to-one image of your hand. Instead of having that be powered by your hand pushing it in, I like to control that electronically to create that image of your hand. And then you could brush your hand over it and feel what it feels like. So if someone put a triangle in there, you could feel, oh yes, this is a triangle. If someone put a circle in there, you'd be like, oh yes, this is a circle, or a circle at a slope, or whatever they want. So that's something that I would like to make. And it would be really easy to learn because people have been feeling for their entire life. You don't have to learn anything new. Like with Braille, you don't. That's not something that comes natural to you. But just about everybody has hands and can feel with them. Like if I gave you a square, you'd be able to tell me, yeah, that's a square with your eyes closed. Certainly not all shapes would be quite so one-to-one, but it's a very natural thing. A lot of people feel things throughout their daily life. It wouldn't be able to do undercuts. So if it wouldn't be able to simulate a perfect sphere, but it could do a hemisphere. Oh yeah, so I don't intend to go blind. But what would be nice is right now this thing doesn't exist. And to my knowledge, people who are blind just don't do 3D design. So I'd like to make this tool to be able to help them. Obviously the contingency plan for if I went blind, that'd be cool. Okay, so what are some quick ideas? One of my first original ideas, which it's a bad idea, but you got to start somewhere. You got to get the ball rolling. What if we just took a 1920 by 1080 monitor and replaced every single pixel with a single pin that'll move up and down, and I control that. Okay, so what are the pros of that? The pros would be fantastic quality. You would have a gigantic image that you would have available to you. You would have great FPS, because if you're controlling each pin individually all at the same time, then it would only take I guess it wouldn't be frames per second, but seconds per frame. But still, it wouldn't take long to update the entire display. It would take a second max, maybe. But what are the cons? The cons would be expensive. Assuming that we spend $1 on each pin, we're looking at like $2 million. And then of course, it's never quite that cheap. It's going to be a lot more than that, but you're looking at probably, I don't know, $25 million to build this thing. I don't have that kind of money. But there's also, oh yeah, it's going to be about the size of a house. It's going to be, if I can find a motor and get a pin density of 1 centimeter, or about, I don't know, half an inch, then and 1,000 of these things in each direction. That's like 10 meters, like 30 feet, and left going up and down, left and right. So, yeah, we're looking at about the size of a house. You're not going to be able to feel that with just your hand. You're not going to be able to get the image that you're looking for. What else is there? Okay, so that moves us to the next idea. What if we just shrunk it down a lot? 100 by 100. Well, you have a reduced image. It's a lot more pixelated. It's going to be harder to tell things. But you retain that, well, it's also only 10,000 pins instead of, 2 million. So it's a lot cheaper on that front. It's a reasonable size. It's about 3 feet by 3 feet, and you can move your hand across that in a reasonable amount of time and scan with your hand and feel what that looks like. At a decent refresh rate. It still retains that fast refresh rate, about less than a second. Cons, still pretty expensive. You got 10,000 pins. Probably it'll cost you $25,000 to get everything all set up, and that's still a lot of pins. Like 10,000 pins, that's a lot to keep track of. Assembly is going to be a nightmare. Okay, well, so what's another one of our ideas? You can multiplex. So let's say instead of having 10,000 motors, we just have 100 motors on a gantry that we can move left and right, and then we have a motor moving that left and right. So so that's 101 motors. So 100 motors up and down, and then one motor that moves them all left and right. Pros, a lot cheaper, 100 times cheaper-ish. So we're looking at about $250 to build that whole thing. I think I could build a mostly working version for $250. You can still keep that same size. It'll be about a meter, 3 feet. However, the refresh rate is going to be abysmal. Let's say it takes 1 second to refresh the display. Then 100 seconds or a minute and a half. Let's just go with that. It'll take a minute and a half for the page to refresh, and then you have to scan it with your hand. And it just waiting that long to do anything is just going to be, that's just not viable. What else is there? Yeah, that's basically all the pros and cons for that one. Okay, what's another idea? 2D multiplexing. Instead of just 1D multiplex, we have 2D multiplex. And this is a lot similar to a 3D printer, where instead of having, or a 2D 3D printer, so 2D printer. So you would move the head left and right and up and down, and then you'd select each pin that you want to set. So you move to the first pin, move that to what you want it to, move to the next pin, set that to what you want it to, and then go through all 100 pins, all up and down, all the way around. And cons of this is that it's 10,000 times slower, and you still have to use 2 motors, one for left, three actually, one to up and down, one for left and right, and then one for forwards and backwards. Anyway, depending on how you look at it. So maybe I could make one of these for $25 if I was okay with having for a prototype or a proof of concept. Yeah, $25 I could probably make that. But 10,000 times slower is way too slow. You'd be waiting for hours, like 3 hours before you actually get an image that you're looking for. Okay, so let's pivot to to features. I want you to be able to, as previously mentioned, here's the point I'm trying to get to. There's a lot of wasted space when you're having to move your hand all around this thing, because a lot of it's just not being used 90% of the time until you finally get around to it. So the smaller the display, the better, the less wasted pins there are. The more pin usage per second is being used. The pin usage per second of the one that was the size of a house is like less than 1%, because you have to go all the way around before you can get back to it. The pin usage per second of the 1 meter 100 by 100 pin display is, I don't know, maybe 10%. I could see you fitting about 100 hands on there. But if we make it smaller and smaller and smaller, what if we just made it the size of a hand? Well, then every pen would be used, and none of them would be wasted, and they're all being used. But you only have, like, let's say you only fit, 10 across my hand, both directions. So you'd only have 100 pins to work with, 10 by 10, 100 pins to work with. That's going to be a very, very bad display. You're not really going to be able to see much with that. But wait, we mentioned something earlier. You can zoom to different areas. So that'll effectively increase your resolution while keeping the same pin density. And then, well, if you zoom in here, you would also want to view something over there. So what if you just moved your hand with the display? So instead of moving your hand across the display, you moved your hand with the display, and the display moved to another location and updated. So that actually brings me to my latest idea, called the I don't know, I don't have a name for it, but it's a new idea where the device is movable and updates based on where it's being located. Let's look at the pros. Pros would be technically an infinite resolution. I guess I should say it's undefined, but as big as your monitor or computer is rendering, you can get to everywhere on there. You just have to zoom out and zoom into different areas, or just move it in one really long line if you wanted to, up to where a single pixel is the size of up to where a single pixel is the size of a pin. This could be cheap because we're only doing 100 by 100 pins. So maybe I could build a ish working one for $250, plus whatever goes wrong. Has a great refresh rate. We still keep that one, that maximum refresh rate of about a second, and it's small. This is something that you could easily store with you, travel with. All good things. Cons. It doesn't have any of the previous cons, except for this new con. It has to be moved in order to get to a lot of areas. So I don't know if it's a con or not. I don't know. But really, it doesn't have any of the other cons. Like it's not too big. It's not grossly expensive. We're not wasting a lot of pins, or usage. So this really seems like a really good thing to spearhead. Okay, so now we're going to pivot to how I'm going to do this, like the nitty gritty. How am I going to do this? How am I going to keep track of where it is, left and right, up and down? Now would be a good time to mention that I don't just want up and down, left and right. I don't want the entire picture to turn with the movement of your hand. I want you to be able, like if you're looking at a square and you move your hand, I want the square to stay fixed relative to the human, and not move. But like if you have a normal mouse and you rotate it, and then you move it left and right, it doesn't. Here, what am I trying to say? When you feel stuff with your hand, like if I wanted to feel this pole right here, if I wanted to feel this pole, I can put my hand on it, I can rotate my hand, I can move it all up and down, and I have a good idea that there is a pole here, and I can feel the general shape of it. Notice that when I rotate my hand, the pole doesn't also rotate with me. Like the pole doesn't, relative to me, the pole stays still. Or I guess I should say, relative to my hand, the pole rotated. It's flipped now because that's on that side. But the pole rotated either clockwise or counterclockwise. I'm not sure how it'll come across on camera. But the pole rotated relative to the hand. With the display, if I want to feel something like a box or a button, and I rotate my hand, I want it to rotate in the opposite direction. I want it to feel like it's fixed to the table, and that we're just feeling something by rubbing our hand over it. I don't want it to rotate with me. If you were to get just a normal mouse and rotate it, if you were to get a normal mouse and move it left and right, the mouse pointer on the cursor will move left and right. But if you rotate it and move it up and down, the mouse pointer will still move left and right. I don't want that. If you rotate it, I want them, and you move it up and down, I want the mouse cursor to also move up and down. Most mice only output, two numbers that I care about. Up and down, left and right, how far it's moved. And I cannot actually keep track of rotation with just that number. Those two numbers. That'll only tell me how far left and how far out, not how much it's rotated. So that there's 3 degrees of freedom that I need. The way that I plan to solve this is by having a second mouse. I need 3 degrees of freedom, 1 for up and down, 1 for left and right, and 1 for rotation. And the way that I plan to accomplish all 3 degrees of freedom is to use a second mouse. Technically, that means I have 4 degrees of freedom available, but 2 of them are going to be lined up, so it just doesn't really matter. I can use some math stuff to determine how far, just to get all three degrees of freedom. I can just use some math stuff to figure that out. And maybe I'll make another video with some animations or whatever showing it. It's pretty cool. It took me a while to figure it out, but it was fun to do. Be a fun video. Yeah, so that's how I plan to keep track of left and right. So how do I plan to move the pins up and down? I just want to use a small stepper motor. I want to use stepper motor instead of a just a standard DC motor, which probably requires me to explain the difference between the two. A stepper motor, a DC motor, you apply voltage to it one way and it'll spin one way. You flip the voltage and it'll spin the other way. That's nice because it's simple. You only need one pole to control it. But there are issues with this, is it doesn't know where it is. You need another sensor to keep track of it, so that's even more wires you have to worry about, more cost, more complexity, things to go wrong, yada, yada, yada. But a stepper motor, it has like discrete locations that it can be in, and you can keep track of that. So you can move it one step at a time, and you can keep track of where it is using that. So you know that if you pulsed it 3 times, you know that it's moved 3 steps. And if you pulsed it 1,000 times, you know that you moved it 1,000 steps. But with the other one, with the DC, standard DC motor, if you pulse it for 10 seconds and then turn it off, you might not know where it is at all. So if you turn it on for 10 seconds in one direction and then 10 seconds in the other direction, it's not going to land exactly where it started. But with the stepper motor, if you move it 10 steps and then 10 steps back, it'll move exactly where it started. You know, within a little bit of wiggle room, but that wiggle room doesn't change. It's not linear. It's actually a fixed amount of wiggle room. It's very small. And I guess that leads me to discussion about like what types of motors I want. I want to find the smallest motor possible, because think about it. If I have a big, you can't see what the motion I'm making, but I'm making a big hoop with my arms. If I have a really big motor that I can just barely bear hug. That I can almost get my arms all the way around. Then if I had 10 of those, you know, it'd be absolutely massive, and there's no way that I'd be able to feel the entire thing with just one hand. So I want the smallest motor for that reason. Another reason, they're expensive. Big motors can get really expensive. So the smaller the motor, cheaper it is. So that's another reason why to get a smaller motor. Another reason to get a smaller motor is they use a lot less power. A big motor like that might take 100 amps. That's a lot of power. Well, I guess it also depends on the voltage, but still, nevertheless, that's a lot of stuff that I don't want to have to deal with. So the smaller the motor, the better. A standard DC motor, I don't know, is like an amp or two, probably a few more than that, if it's not being, taxed too hard. But like, if I do that, then I'm going to need a whole driver circuit and yada, yada, yada. I was actually able to find motors so small that from a single source, that kind of tells you a little bit of foreshadowing there, but from a single source, I was able to find a super rare, not rare, but a super obscure motor that supposedly draws like 20 milliamps. That's 20 thousandths of an amp. And it's actually so small, I don't even need an external driver circuit. I can power that directly from a microchip. So like normally microchips, they're just brains. They only do stuff, they do thinking. They don't do the heavy lifting. That's what the drivers are for. But this motor, supposedly it's so small that I can actually drive it with the brain. So it turns out that was wrong. When I actually ordered it and tested it, it was like more like 200 milliamps. I was like, okay, well maybe the guy just told me wrong or something. But well, not told me, but like, the one single source that I found it on. But still, 200 milliamps, that's not bad. And the motors are fantastically small. So they're smaller than like a pencil. They are 4 millimeters. It's like basically the size of a pencil, if you need something to compare to. But yeah, like really small motors. And they have a nice carriage on them. They have a gear reduction already installed. They have a carriage already installed, so they already have. It's a linear actuator. It's no longer just a spinning motor that I have to design the linear actuator portion of it, the gantry. And they're like $1 each, so that's great in terms of pricing. And I think it may even be a little bit cheaper, but nevertheless, it's still great pricing. But a bit of a bummer that they draw 200 milliamps instead of 20. That means I have to make a driver circuit for it. Which I actually just finished. Actually, I wanted to end up talking about it when I get back to my room. I know, whatever. I'll have to show that to you later. Oh yeah, how am I going to drive, 100 motors? Or even how do they even think I was going to drive 10,000 motors when most chips, most brains only have like 10 pins, 20 pins to work with. How am I going to draw 100 or 1,000 or whatever? And technically, each stepper motor needs 4 pins. Needs 4 conductors. So how am I going to plan to do that? I plan to use muxes to do all of that. And a mux, it's probably attacked by a bug. A mux is just a multiplexer, right? With 3 pins, or 4 pins actually. With 4 pins, I can control 16 pins, and just it's the combination of those 4 pins that lets me select a single thing. And so yeah, I plan to use those to control all the motors, to control the driver, which then controls the motors. Yada yada yada. I finished before I step all the way into what I'm wanting to design. I needed to test, make sure that I can actually drive these motors. I was planning on using some off-the-shelf, kind of expensive stepper motors, but they don't do the low enough voltage that I'm looking for. They only really trigger at like 8 volts. So when I'm trying to pulse set at, with 5 volts only, actually it's more like 3, with only 3 volts, the things they just don't work. So I made a test little PCB. I worked out some kinks, because I'm glad I did that, because I would have made a lot of mistakes. But yeah, I worked out my kinks. I'm able to drive the motor. I think it takes about, I might not use the full stroke, because the full stroke is like an inch long almost. So I may just stick with half a stroke, but nevertheless, I'm looking at about half a second to a quarter second refresh time, which is pretty good. Which means that as you're moving your hand around it, you'd be able to see, you'd be able to update what you're looking at about every quarter second, half second. So this is what I was trying to explain earlier. With a single mouse, it can only track up and down, left and right. Okay? If I rotate it and then move up and down, the computer doesn't think it's moving up and down. It thinks it's moving left, right, not up and down. When you're using the tactile display, I want it to know absolute where it's moving relative to the table that it's on. So if I rotate it like this and then move it up and down, it will actually actively figure out that it needs to move up and down and not left and right. So the way that I said I wanted to accomplish this is by using 2 mice. So to explain that thing that I was talking about earlier, if I want to get a rotation, I needed 2 mice. So I'm going to use the one that's closest to me. I'm going to use that for up and down, left and right. Okay, but I'm going to use the one all the way on the one that's farthest from me. I don't know whether it's left or right because of things get flipped with the camera and stuff. But the one that's farthest away from me, nearest my pinky, I'm going to use that for just up and down. So if I read the mice and I see that both mice A and mice B have moved up, then I know I moved in a straight line. Like if they're the same number, then I moved in a straight line. But let's say that A was negative and B was positive. So keep in mind that as you move your mice, like a normal mouse, if you were to move it like if you were to move a normal mouse like this, it only thinks it moved up. It doesn't think that it moved off to the side. It only thinks it moved up, because it doesn't do rotation. And as long as you move perfectly in line with it, it'll still think it's moving up. So with these, if I move the one closest to me down and the one farthest from me up, then I have rotation. And I can measure that too. One will be negative, one will be positive. I can do some fancy math stuff, and bada bing, bada boom, I know that I moved. And so I can use that same math to determine that if they're both positive but one's smaller than the other, then I've curved. And same in the other direction, down and off to the side. And with all of those, I can actually get my current angle, and I can get my current displacement. So I can move up like this, angle it, off to the side, go down, come back, rotate it some more, come back up, and it'll still think that I'm at the middle. And you might think, oh, how good can some duct tape mice be? Pretty good. In terms of the angular displacement accuracy, it's really good. It's as good as I can tell. because you know duct tape and stuff. If I move it around 360 degrees, it says 360 degrees. It might say 301, 359, but I'm eyeballing it, and that's as good as my eyeball can get. So as good as my eyeball is, it's 360 degrees. And left and right, up and down, that's normally pretty well. If I move it 6 inches in one direction and then move it all the way back, I'll be off by about a quarter inch sometimes, and I think that's just some tuning that I need to do. So before I spend an eternity doing tuning, I'm going to work on other features first. So that's the general idea of how how I'm going to keep track of rotation. Look at her go!